Today we're going to be looking at the analysis of one categorical variable. Specifically, we're going to focus on descriptive statistics. Before we begin, I want to remind you what categorical data is. Categorical data are groups or category names. So you can't have an average calculated for it, and there are no units connected to it. So we're first going to look at the descriptive statistic using numeric summaries. So there are three types of numeric summaries for categorical data, the first of which is frequencies. So frequency is the number of individuals or the count of individuals in a specific group or category. So if I were looking at eye color, the number of people who have brown eyes, that number or count would be referred to as a frequency. The next numeric summary that we have for categorical data is referred to as relative frequency. So it's referred to that because it's the count of the individuals relative to the total. So, for example, if I was looking at eye color, a relative frequency for brown eyes would be the count of people with brown eyes over the total number of people I had with eye color data. The next numeric summary that we have for categorical data is referred to as a percentage. A percentage simply takes a relative frequency and multiplies it by 100. These are the three numeric summaries that are available for categorical data. Next, we're going to look at where those numeric summaries can be shown in terms of a table. Here you can see a frequency table. So again, this is categorical data, and in the left-hand column, you're seeing the different categories that are represented. So this is a table of cars and the country of origin. So here we have American-made cars, European-made cars, and Japanese cars. And then the frequency in each group. So the number of American-made cars is 253. The number of European cars is 73. And the number of Japanese cars is 79. If I wanted to calculate a relative frequency, and notice that that is not a column offered in a frequency table, this is a SPSS frequency table, but also the frequency tables shown in your textbook don't have relative frequencies. If I wanted to calculate a relative frequency, I would take the count, so 253, relative to the total of 405. So 253 divided by 405 would give me the relative frequency. Calculating that proportion and then multiplying it by 100 would give me this 62.3%. So one thing that's different between this table and the tables that are shown in your textbook, this table gives you a cumulative percent, which means it adds the percent shown with the percent for the next group to calculate a cumulative percentage. So here, because our American cars are the first cars shown, I have 62.5, and then if I add the 18, it gets me to that 80.5. And then finally, if I add that 19.5, it gets me all the way up to 100. So cumulative percentages simply add the percent from the row before with the percent that's shown for that group. The next thing we're going to look at is graphical displays for categorical data. The first one we're looking at is a bar graph. So a bar graph is specifically for categorical data. It tends to be the case that the horizontal axis, and sometimes people refer to that as the x-axis, that's going to show the different categories, whereas the y-axis or the vertical axis will show the frequency or count of individuals in that group. So for example, for the category apple in nicest fruit option, there's approximately 35 people who said that apple is the nicest fruit. Whereas for oranges, there's approximately 30 people who say that oranges are the nicest fruit. So one thing that you'll recognize in terms of a bar graph is that the bars tend to not touch, so they're not connected to each other. So this is one graphical display for categorical data. Specifically, this is a bar graph. The next graphical display that we have for categorical data is called a pie chart or a pie graph. So with a pie chart or a pie graph, this is going to give different areas or pieces of pies for each of the categories. So in birthday wishes, where people are wishing you a happy birthday, we're shown different options for email, Skype, phone, etc. So each of these colors are connected to a piece of the pie. So it appears that for this pie graph, Facebook has the largest percent or frequency of people who are saying that's how they were wished a happy birthday. So the area of the pie corresponds to a percent represented in each category. So here we have the different categories, and then Facebook is shown over here as a legend, the dark blue, and it appears to be the largest represented group over here on the pie graph. The next thing that we're going to discuss is looking at variability in categorical data. So this can be challenging because it's not as intuitive as you would like it to be. When you think about variability in general, it's values that vary from individual to individual within a population or a sample. So here the concept of variability is a measure of unlikeness or differences in the data values. So when looking at a bar graph, if I were to ask you which of these three bar graphs had the most amount of variability, a lot of you would want to choose this one in the middle because the bars are so different in height. But if you think about it in terms of agreement, the most disagreement is happening actually over here in this first graph. So when the bars are very similar in height, it indicates that there actually is a lot of variability. However, if the bars have very different heights, as shown in the second graph here, there actually is a lot of agreement, and because of that there's less variability. So if I were to rank these graphs in terms of which one had the most variability, I would choose this first one with the troops. So because the bar heights are so similar, there's the most amount of disagreement between these, or within the options shown for troops. So this has the most variability. The one that had the next level of variability would be what's shown here, because people are agreeing a little bit more than what's shown in the first graph. And then the one with the least amount of variability would be the one in the middle. And that's true because there's more agreement. So 90% of people say that that was the right decision, and only 10% say it's wrong. So in terms of agreement, if there's more agreement, there's less variability. And when you're looking at it in terms of the height of the bars, if the height of the bars are very different, it indicates less variability, as is shown here. And if the height of the bars are very similar, it indicates more variability because there's more disagreement between the groups. So this is looking at descriptive statistics for categorical data.